Hey, Marion. So number 29 on page 297 is not part of the review. It's actually part of chapter 8, section 7, where we're learning how to multiply and divide radicals. So in this section, number 29, it's asking us to multiply or divide as indicated. And right here, because it's a fraction, we need to divide, okay? And we also have to remember our rule. Our rule is if we have the index of b, all right, that equals x. If you remember, that is a over b, right? Where b is the index, and this is our rule that we have to remember, where you have the index and then you have a variable or a constant raised to a power. You can rewrite it as this constant or coefficient to the a, the exponent, over the index. Okay? So we have to remember this. All right? So what we need to do is we need to rewrite each one of these. So knowing this, we can rewrite the top as that, and the bottom as that. Because we have to the power of 1, and when you have a square root with no index, then it's known to be a square root, which would be 2. So there's an invisible 2 here. There's an invisible 1 here, right? And there's an invisible 1 here, right? So by this property, we know that we can rewrite it as 5x to the third over 3x to the 1/2. Now, when we divide exponents, if you remember dividing exponents, if I had x to the third over x squared, that's the same thing as x to the third divided by x squared. And when we divide exponents, all we do is we keep the coefficient and we subtract the exponents. Okay? When we're multiplying, x cubed times x squared, right? You keep the variable and then you just add. You just add the exponents. Okay? So when we're dividing, we subtract the exponents. Okay? And when we're multiplying, we add the exponents. But the thing is that the variables have to be the same, which they are. It's x and x. Okay? So, what we have here is we first of all have to deal with the coefficients. So 5 over 3, so 3 into 5, it doesn't go evenly, so we keep the fraction 5/3. All right? And then we have x to the third divided by x to the 1/2. Well, x to the third, x to the 1/3 divided by x to the 1/2. All right? How do we do that? Well, that would be x to the 1/3 minus 1/2. Right? So how do we subtract fractions? Well, we have to get a common denominator. And a common denominator between 3 and 2 is 6. So that's going to equal x to the 2 over 6 minus 3 over 6. which gives us x to the negative 1 over 6. Okay? Now, x to the negative 1 over 6, remember, x to the negative 1 is what? 1 over x. All right, that was a rule that we learned. All right, so if we have x to the negative 1 over 6, that's equals to 1 over x to the positive 1 over 6. Okay, so we know that x to the 1/3 divided by x to the 1/2, right? We subtract and we get x to the negative 1/6, which we know is 1 over x to the 1/6. So this is multiplied by 1 over x to the 1/6. Let me do that better here. It'd be the 1 over 6, right? Which equals 5 times 1 is 5. 3 times, well, 1/6, if we go backwards, the 6 is the index, so the 6th root of x. Okay? Now, this is a tricky one because when you have 5 over 3 to the 6th root of x, can we have a radical in our denominator? No. So they're testing us. So I need to rewrite this. 5 over 3 to the 6th power of x. All right, and I have to multiply by something to get that radical out of there. So I'm going to multiply by the 6th root of x over the 6th root of x, which is basically just 1, right? I'm multiplying this by 1, all right? And what that does is that makes this your denominator. I've got 3 times 1, so that's 3. The 6th root of x times the 6th root of x is going to be x. And then up here, I've got 5 times the 6th root of x. And that is your answer. That's a tough one. That's a really, really hard one. But that is how we do it. Okay? You gotta just remember when you're dividing, all right, you subtract the exponents. All right? And this is a tricky one because when you subtracted the exponents, you get a negative exponent, right? Which is actually a negative fraction exponent, which makes it even more difficult, right? But if we just work with the rules that we know that x to the negative 1/6 is 1 over x to the 1/6. We multiply it to our coefficients, which is 5 over 3, right? And we also know that you cannot have a radical in your denominator, so you have to rationalize that denominator. So we multiply it by the 6th root of x, 6th root of x, and that's how we get to 5 times the 6th root of x over 3 times x. This is a really hard one, okay? But do your best to understand how we got through that and that explanation on how to do that. Rewatch the video a couple of times and hopefully you'll understand how we got to that. So very important to know this rule. It's very important to know that you cannot have a radical in your denominator, so you have to continue simplifying it. And it's also very important to understand our exponent rules, right? If you have the same variable, right, or the same root, right? So x is the root, x is the root. So if you have the same root, then you can divide or multiply those roots and those exponents, okay? If I had y to the 3rd divided by x to the 1/2, I can't do that because the roots are different. They have to be the same. The roots have to be the same. So I cannot divide that, all right? That just equals y to the 1/3 over x to the 1/2, which also equals the cubed root of y over the square root of x. Can't have a square, you can't have a radical, so I'm going to multiply by square root of x, and that's going to equal cubed root of y times the square root of x over x. Okay? So that's what this would equal. Okay? But since we had the same root, we could simplify, right? With the same root, that becomes x to the 1/3 minus 1/2, right? Which equals x to the negative 1/6, which equals 1 over x to the 1/6. Right? That's how we got that right there. Okay? All right, hopefully that helps you. If you have any other questions on this or you need further explanation, just let me know and I'll do another video for you. Thank you, Marion. Bye.